Assalamu alaikum to all of you. Today is a lesson about topic physics, uh, gravitation. Unit number 6, gravitation. And in this lesson, first of all, main topics we will study. Now let's start to what is gravity first of all, and now understand what is gravity.
Ask anybody around you this simple question, what is gravity? And what you'd probably hear is, it's something that pulls objects towards the earth, or it's a force exerted by the earth to pull objects towards it. Now before we get to the basics of gravitation, there is one thing I want you to understand well. Rather, there's one thing I want you to forget. Forget the fact that gravity has got to do only with the earth and the objects close to it. That's not gravity. We'd see examples where objects are falling to the ground and we assume that it's the only concept we need to know about gravity. Yes, of course it's gravity that pulls the objects towards the earth, but that's not the only thing you need to understand about gravity. So what is gravity? Consider your screen to be the universe, and these are any two objects in the universe. They could be planets or humans or animals or whatever. Just that they both have non-zero mass. In this case, both objects are pulling the other object towards each other. This object is pulling this one towards itself, and the other object is pulling this one towards itself. This attractive force between any two masses in the universe is called the gravitational force. So the gravitational force is the attractive force between any two objects with non-zero mass separated by a distance. It's not only the force that Earth uses to pull objects towards it. But yes, as all of us have Earth as our habitat, most examples we see for gravitation will relate to the Earth pulling objects towards it. But you should know that it's not the only force that explains gravitation. In the case of Earth and a human being, the Earth is one object and the human being is another. Both are pulling the other towards themselves. But why does this happen? If you do a lot of research onto what gravity really means, you may find out that gravity is not actually a force and it's just an illusion. So for now, it's enough to know that gravitational force is just the attractive force between any two objects with non-zero mass separated by a distance. After knowing the basics, you'd probably have many questions in mind. Does the apple fall towards the earth, or does the earth move towards the apple? If two objects always attract each other, why don't two humans get pulled towards each other? Why don't two stars collide with each other? After watching our videos based on gravitation, you will be able to answer all these questions and understand various concepts related to them. Happy learning!
Now we have already know about gravity. Now in these topics we will study today Newton's law of gravitation and gravitational field, weight, mass of earth. Now let's start to understand law of gravitation.
We saw that the gravitational force is the attractive force between any two objects with non-zero mass separated by a distance. So does the apple fall towards the earth, or does the earth move towards the apple? The celestial object is an apple. Based on what we learnt about the gravitational force, both apply an equal force to attract the other object towards itself. So if the forces are equal, which one will accelerate more? Based on the Newton's second law, we know that the force applied is the product of mass and acceleration. So the acceleration will equal force over the mass. The acceleration is inversely proportional to the mass. If the mass is more, the acceleration will be lesser. As the mass of the earth is much more than the mass of the apple, it is the apple that accelerates towards the earth and not the other way around. Hope that makes it clear. Now the question is, how do we quantify this force? To understand this, we need to understand a simple concept. And this simple concept is called the universal law of gravitation. Say there are two objects A and B separated by a distance d. The distance between the centers is considered the distance between the two objects and not this distance. Assume that the mass of object A is m1 and that of object B is m2. As object A is bigger, let's assume m1 to be bigger than m2. The universal law of gravitation says that every object in the universe attracts every object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Let me repeat. The force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. With this data, we can write it mathematically like this. So if the mass of any of the objects increases, the gravitational force will have more magnitude. And more the distance between the two objects, the lesser will be the gravitational force. Directly proportional to the product of the masses and inversely proportional to the square of the distance between them. This can be written as F equals G times m1 times m2 over d squared. G here is the constant of proportionality and is called the universal gravitational constant. The equation can be modified and written as G equals F times d squared over m1 times m2. The value of G was found out by Lord Henry Cavendish using a torsion balance. The universally accepted value of G is 6.673 times 10 raised to negative 11. What will be the units of G? Force is newtons. As the distance is in meters, we have meters squared. And as the mass is measured using kilograms, we multiply this with kilograms raised to negative 2. This is the value of the universal gravitational constant. Most of us think that mass and weight are pretty much the same thing.
Now we understand gravitational field known as to weight. What is weight?
Let's accept it. Most of us think that mass and weight are pretty much the same thing. Are they? No, they're not. There's a very simple way to understand the difference. Mass is simply the amount of matter that's present in the object. Now consider two situations. One in which an object is on the earth and second in which the same object is on the moon. Will the mass of the object be different in these cases? To answer this question, we ask ourselves another simple question. Will the amount of matter present in the object be different in these cases? Absolutely not. The matter in the object is not changing at all, which is why the mass will be the same in each of the cases. The mass of an object remains constant no matter where it is placed. The standard metric unit of mass is the kilogram. Another concept we'd learnt about an object's mass was that it is a measure of its inertia. Greater the mass of an object, greater will be its inertia. Inertia is nothing but the tendency of an object to resist change in its state of motion. So now we have an idea about what mass is. But what's weight then? How do we understand the weight of an object? Mass is nothing but the measure of how much matter an object has. Weight is a measure of how strongly gravity pulls on that matter. It's the measurement of the gravitational pull of an object. Let's understand this using a simple example. Say there are two places, place A and place B, and there's an object of mass m. In place A, the pull of gravity is x units, and in place B, the pull of gravity is 2x units. Clearly, the pull of gravity is stronger at place B. Now understand this well. The mass of the object will be m at both the places, but the weight of the object will be greater at place B because the pull of gravity is stronger. As the gravity is twice as bigger, the weight of the object will be twice as much at place B as compared to place A. So the weight of an object is a measurement of gravitational force acting on it. How can we understand weight using a formula? We know the Newton's second law of motion, which says that the force acting on an object is the product of its mass and acceleration. When it's acceleration due to gravity, we can replace a with a lowercase g. This force due to gravity is nothing but the weight of the object. So if we consider the weight of an object to be uppercase W, we can rewrite this equation as W equals m times g. So the weight of an object is the product of its mass and acceleration due to gravity. What will be the SI unit of weight? Can you guess? It'll be the same as that of force, Newton. As the value of g at a particular place is constant, we can also say that the weight of the object is directly proportional to its mass. Here's the main takeaway from this video. The object remains constant everywhere, whereas its weight depends on the gravitational force at the location.
Now, question number 1, we have already discussed about the Newton laws of gravitation and proof. This is the most important questions. First of all, you can write the definition of Newton law of gravitation. Every body in the universe attracts every body with the force which is directly proportional to the product of their masses and inversely proportional to the square of distance between them, their centers. Now you can consider two masses m1 and m2. The distance between both masses you can represent it the r, and the force of attraction between those masses you can the same in magnitude and opposite in direction. Now understand this law. Let us consider two bodies of mass m and m. You can write m1 and m2 here. The distance between m1 and m2, their center is r. According to this statement, the force of attraction between two bodies is directly proportional to the product of their mass. You can write in the mathematical form, force is the product of directly proportional to the two products of mass. The gravitational force of attraction is inversely proportional to the square of distance between the center of the mass of the body. Therefore, we can write in the form of F is inversely proportional to the 1 over r square. Because the force of attraction we can depend upon the radius or distance between them. Combining equations 1 and 2, we can combine both equations. We can write in this form. F is directly proportional to the m1 and m2, and we can write is the directly proportional to masses, and the force we can write in the inversely proportional to the r square. Now we can represent it the directly proportional sign we can remove and put here the gravitational constant. This is the gravitational constant. G is constantly proportional, known as universal gravitational constant. Its value is 6.673 multiplied 10 power minus 11 Newton meter kg is the unit of Newton of gravitational constant. This is very small value. G remain constant everywhere. This is a question for define Newton law of gravitation. Now we can represent here what is the G and capital and small g difference between. Now write down the difference between G and small g and capital G. You can write difference. It is the universal gravitational constant and is the acceleration due to gravity which determines the gravitational force attraction per unit mass. This is the G for you can write Newton first law, second law of motion. F is equal to ma and W is equal to mg. G is the same value everywhere in the universe. You can measure the value of G in universe in every planets. You can measure the value of G Earth, and you can measure the value of G at Moon will be same, but the small g will different places. It is the different values at different places. It is depend upon the gravity. This is the universal gravitational constant. You can measure the value of capital G in everywhere of universe and every planets. It will be same. Now small g will different with different places. Its value is 6.63 multiplied 10 power minus 11, and its near earth surface has the value of 10 meter per second square or 10 Newton kg. But you can measure the value of small g. You can 6 times less than value of G on moon. Now this is the difference between small g and capital G. Now characteristics of gravitational forces. What is the characteristic of gravitational force? Now it's always present between every two objects because of their mass. We have already discussed in lecture. It exists everywhere in the universe. We have of course already discussions. It is form an actions reactions pair. Now if two masses, you can write the both masses attraction to each other. This is the gravitational force of these masses. It is independent of medium between the objects. It is directly proportional to the masses of the objects. It is inversely proportional square of the distance between the center of object. Hence, followed by in inverse square law. It's follow the inverse square. What is the inverse square law? You can write a formula for. We have already write what is the formula of universal gravitation. Now this is a formula for universal gravitational, and we can write already in this lecture. I hope you all are understood today's lesson.